Welcome back to Liger Science, and today we'll be trying to answer the question, how can everyone safely meet each other in person during the COVID-19 pandemic? So the reason I decided to make this video is because I saw this pretty famous tweet on Facebook. It says, if the mask work, why the 6 feet? If the 6 feet work, why the mask? If both work, why the lockdown? I love how the capitalization is so chaotic. And the spaces, it's not even evenly spaced. So my response to this is that they don't actually work. Like masks, they don't work. The 6 feet, they don't work either. And the lockdown, they're supposed to work, but people still go outside, as I mentioned in my previous video. So this is exactly why COVID is still happening. If these actually work, then the virus would have been long gone. But no, none of these work, and still we're still here suffering. And that's not the only problem. The reason humans are still dying is because of people like the post author here. They're like spreading misinformation, which basically makes the situation a lot more worse. So in this video, I'm going to demonstrate their whole argument in a little Python simulation. Here I used Blender and its built-in physics engine. So I basically turned on gravity and gave it some acceleration for the particles and got the human models from the internet. So as you can see here, on the left they're 6 feet apart, and then on the right they're 3 feet apart. This really shows how important social distancing is. Uh, but the problem is that these particles are millimeters in diameter. They're droplets of spit, but coronavirus can also be carried in the air because they're so tiny, they're micrometers in length, and so they reach terminal velocity very quick and don't accelerate downwards. So they're carried around by air and wind with drag. So I'm going to show you that social distancing isn't enough. So here's my dirty Python code. It is really terrible, a lot of spaghetti stuff in here. But here is the COVID particle class here. It's got density, mass, x, y coordinates. And so basically I'm using matplot and numpy as my main packages. So we've got the particle class that I'm gonna use. We've got a human class, and then the human isn't really gonna move. And then we've got like other functions that are useful that I copied from Stack Overflow. So here's the main function that I'm gonna run. So we've got the main, and so if we run it, it's basically gonna render using matplot. So I rendered this in Blender and sculpted all the 3D models and stuff, but then imported it into Python. But boy, Python is hell of a shitty programming language. That thing is so bad and so unnecessarily long to do. Like, Python is the worst language ever and it doesn't even work. Gosh, I hate Python so much. But anyways, as you can see here, the particles still manage to travel really far over obstacles, and not only that, it also takes a really long time for them to finally fall and rest on the ground. It takes around 6 to 10 minutes for most of the particles to disappear. So this is what happens when someone coughs in a room in just 10 minutes. So you can see how quickly it spreads out and infects everyone. So the blue here means that it has a low rate of infection, and the red means it has a high rate of infection. And you can see that here they're mostly like green, and so it is sure going to infect everyone in a room. So this is a simulation without anyone wearing a mask. And here is another simulation where everyone is wearing masks. So while coding this one, I realized that Matplot has 3D mode, so I used it and it turned out really great. And so here, the infected person is wearing mask and everyone else is too. So you can see that it it doesn't really go that far, but still it went to the other side of the room. And so even though it has a low most of them are blue and it has a low rate of infection, sitting in a room for hours will increase your risk of infection. So this is still a huge problem. So the thing is, masks and the social distancing won't stop you from getting COVID, but it will surely reduce the risk.